Lesson: Differences between traditional and AI systems. The differences between traditional systems and artificial intelligence systems are fundamental and transformative, reshaping the way industries operate and how decisions are made. Understanding these differences is crucial for professionals in the field of AI compliance and ethics auditing, as it informs the oversight and governance of AI applications. Traditional systems, often rule-based and deterministic, have long been the backbone of information processing. They rely on predefined instructions and logical sequences to perform specific tasks. In contrast, AI systems are designed to learn from data, adapt to new information, and improve over time, thus introducing a level of autonomy and unpredictability absent in traditional systems. Traditional systems are built on explicit programming, where every possible scenario and response must be anticipated and encoded by developers. This approach works well for tasks that are well-defined and where conditions are unlikely to change unpredictably. For example, a traditional payroll system calculates wages based on fixed rules like hours worked and pay rate. Any deviation, such as an employee bonus, requires manual intervention or additional programming. This rigidity can be a limitation in dynamic environments where conditions change rapidly and rules cannot be easily predefined. AI systems, however, are characterized by their ability to process vast amounts of data and derive patterns without explicit programming. Machine learning, a subset of AI, enables systems to learn from data inputs and make predictions or decisions based on that learning. For example, an AI-based recommendation system on an e-commerce platform analyzes user behavior and preferences to suggest products, adapting its suggestions as it gathers more data. This ability to learn and adapt provides AI systems with a significant advantage in environments that require quick adaptation to new data or unforeseen conditions. One of the practical frameworks for understanding AI systems is the CRISP-DM model, which outlines a structured approach to implementing AI projects. This framework consists of 6 phases: business understanding, data preparation, modeling, evaluation, and deployment. Applying CRISP-DM helps professionals systematically address each stage of an AI project, ensuring that the system is aligned with business goals and is ethically and technically sound. The differences between traditional and AI systems can also be observed in their approach to data. Traditional systems often use structured data stored in relational databases, which require a rigid schema and predefined relationships. AI systems, on the other hand, excel at handling unstructured data such as text, images, and audio. Techniques such as natural language processing and computer vision allow AI systems to interpret and analyze data types that traditional systems struggle to process. This ability is particularly beneficial in applications like sentiment analysis, image recognition, and voice-activated assistance. The shift from traditional to AI systems also introduces new ethical considerations. AI systems, by virtue of their learning capabilities, can develop biases based on the data they are trained on. If the training data contains biases, the AI system may perpetuate or even amplify these biases, leading to unfair or discriminatory outcomes. Traditional systems, while not immune to bias, are typically easier to audit and correct since their decision-making process is transparent and rule-based. Addressing bias in AI systems requires rigorous testing and validation, as well as the implementation of fairness-aware algorithms and bias detection tools. A practical tool for ensuring ethical AI deployment is the use of model interpretability techniques such as LIME and SHAPE. These tools help professionals understand how AI models make decisions, providing insights into the factors influencing predictions. This transparency is essential for auditing AI systems, as it allows auditors to identify potential biases and ensure that the model's decisions align with ethical standards and regulatory requirements. Another significant difference between traditional and AI systems is their approach to problem solving. Traditional systems follow a linear, logical process to arrive at a solution, often requiring human intervention to handle complex or unexpected scenarios. AI systems, particularly those utilizing deep learning, can tackle complex problems by simulating human-like reasoning and decision-making processes. For instance, in medical diagnostics, AI systems can analyze medical images to detect anomalies with high accuracy, sometimes surpassing human experts. This capability is due to the system's ability to learn from a vast number of examples and improve its accuracy over time. However, the deployment of AI systems also comes with challenges, particularly in ensuring compliance with legal and regulatory frameworks. AI systems must be designed to comply with data protection regulations, such as the General Data Protection Regulation in the European Union, which mandates transparency, accountability, and user consent in data processing activities. Compliance professionals must ensure that AI systems incorporate privacy by design principles and provide mechanisms for data subjects to exercise their rights, such as accessing, correcting, or deleting their data. To address these challenges, professionals can utilize frameworks like the AI Ethics Guidelines developed by the European Commission's High-Level Expert Group on AI. These guidelines outline key principles such as human agency and oversight, technical robustness and safety, privacy and data governance, transparency, diversity, non-discrimination, fairness, societal and environmental well-being, and accountability. By adhering to these guidelines, organizations can ensure that their AI systems are developed and deployed in a manner that respects ethical norms and regulatory requirements. The evolution from traditional to AI systems also necessitates a shift in skills and competencies for professionals involved in system development and auditing. While traditional systems require proficiency in programming languages and logical problem solving, AI systems demand expertise in data science, machine learning algorithms, and ethical considerations. Tools such as TensorFlow, PyTorch, and scikit-learn are essential for developing AI models, while platforms like IBM Watson and Google Cloud AI offer comprehensive solutions for deploying AI applications. In conclusion, the differences between traditional and AI systems are profound, impacting the way organizations operate and make strategic decisions. AI systems, with their ability to learn and adapt, offer significant advantages in dynamic environments, but also introduce new challenges in terms of ethics and compliance. By leveraging practical frameworks such as CRISP-DM, model interpretability tools like LIME and SHAPE, and adhering to ethical guidelines, professionals can effectively manage these challenges and ensure that AI systems are deployed responsibly and ethically. As AI continues to advance, staying informed about the latest developments and best practices will be essential for professionals tasked with auditing AI systems and ensuring their compliance with ethical and regulatory standards.